accepted.
Okay, so I'm still hoping some people will still arrive. Yeah, last talk, usual, but it wouldn't hurt maybe 30 seconds or 1 minute. Let's see. There's one. Okay. Having a good time here in Krakow? Krakow, right? Krakow. So this is my first time here, lovely city. I've been to Warsaw like several times, and I couldn't believe what I'm seeing here. Totally different. And this place is such amazing, beautiful place. So many things to see. Unfortunately, I'm leaving a little early. After this, I have to go straight to the airport, and that's it for me. But I'm coming back here. This is one of the places that I can see myself in the future. I'll be coming back. So, yeah, so much for that. Again, thank you for coming here, spending time with me, learning new things. And thank you also for the sponsors. Without them, this wouldn't be possible. And thank you again for Devoxx Krakow for inviting me here to share what I know. So I'm here to talk about Turbopack and RSPack. These are bundlers, JavaScript bundlers. And a little bit about me, I'm Devlin Duldulao, originally from Manila, Philippines, but I live and work now in Oslo, Norway for 4 years. I'm a Microsoft MVP, and I've written some books in Angular with Spring Boot, co-written that, and co-written another book, Practical Enterprise React TypeScript. And my very first book is this ASP.NET Core in Vue.js. So much for that. So this is a car design, right, that shows you different pieces that were put together to build this car. Similarly, in software applications, these pieces are called, say, modules. You can also say that in React, React components. These are building blocks of, example, React application. So creating modules to build a software or a car gives benefits like isolation. That's first. So isolation allows people to work individually on the car or the application without delaying someone. Another one, composability. So clear boundaries for each individual component. They're able to compose each piece together to create fully functioning feature. Another one, reusability. Can reuse the same components. For example, in this car would be wiper, wheels, seats, etc. Organization also is a feature here. So the effect of each individual piece having clear boundaries for how they interact with each other. So those are 4 that you'll often get from, composability or those things. So how do we modularize our code before? So back in the day, we have this IIFE or IFE. So this one mimics a module scope, right? You can hide variables, self-contained, etc. And IFE helped us create module pattern back in the days. So that's one very first encounter. And another one would be CommonJS. So this is built for Node.js originally. And characteristic would be asynchronous. And then for the asynchronous counterpart, this is what we call AMD, synchronous module definition, hence the name. So this is an example of AMD would be required.js. So AMD came to fix dependency resolution and pollution of the global scope. So we use CommonJS and AMD to share libraries through NPM packages. So how do we use CommonJS in the browser if it's built for Node.js and synchronous? So for the browser, we're going to use, we were using Browserify before, so it's made to support CommonJS in browsers. It's a module bundler that reads all requires and module exports and bundle all JS or JavaScript files, right, into one single file. It's often called bundle.js. So some characteristic here in Browserify, it needs gulp and grunt as task runners to run. And then after that, after Browserify, we encounter this Webpack. Webpack is a module bundler, and that can do things more than what Browserify can do, such as it can detect the code you don't use to exclude it while combining files, serialize the code and load it only when it's necessary, monitor file alterations and transpile code to ES5, etc. And it can also concatenate multiple files together into a single bundle for the browser. But the problem is that this process becomes increasingly slow as the app adds more code and dependencies. And of course, I'm not sure with anyone with you if you experience really huge Angular application or React application, and you've noticed that the HMR or the hot module replacement is kind of sluggish or takes several seconds before you can see the changes, right? And the effect of that, of course, if the developer writing code and it takes a few seconds before you can see changes, sometimes like notification on the mobile phone would check it, and then you're gonna lose your concentration, developing app because you're now your attention is now switched to your mobile phone because of this taking so much time to see these changes. So Webpack's large-scale incremental build performance. So you have this architecture, not incremental plugins, can do anything, and backwards compatible. Large changes are hard to do. Cache invalidation, too sensitive. Cache lookup costs, many cache lookups. And that's why in 2015, ECMAScript modules were introduced. ES modules is a module system that is now baked in JavaScript language or ECMAScript. So out of the box, it supports async loading in modules. The import keyword, the export keyword, but it needs server to be able to fetch with import, as it doesn't work with file protocol. So before I'm going to introduce to you Turbopack and RSpack, I'd like to show what Vite is. So this is currently what we're using in our company. It's also a module bundler that help us write code in an efficient way, and it helps the HMR very fast, increasingly fast when seeing changes in the UI. So in Vite, there are two things that you have to remember here. Vite has a server, dev server here. I'm not sure it's like yeah. So a dev server is a build and the build command, or you can also call it a pre-configured bundler. So the dev server provides rich feature enhancements over native ES modules, extremely fast hot module replacement, for instance, and have here ES build. So this is a bundler being used in development mode, but for production, it's different. So in Vite, you have different bundler for development, and for production, they're using roll-up plugin. So much for that. So let's focus now in Turbopack. So Turbopack is written in Rust by the creators of Webpack and Next.js at Vercel. So Turbopack delivers a swift and versatile development experience for applications of any scale, thanks to its progressive behavior and adjustable packaging approaches. So the question is, why Turbopack? So why Turbopack? First is incremental by design. So it knows, which files to rerun. So it's smart enough to know which files to rerun. That's one feature. Another feature would be the ecosystem is friendly. So it supports TypeScript, JSX, WebAssembly, and more. Another one would be lightning fast HMR. So faster HMR than Webpack, no matter how big is the app. So here you can see the benefits of for example, Vite or Turbopack or RSpack, where it doesn't matter how large the application, because you get the same HMR when you're writing code and checking the changes. Another feature here in Turbopack would be this RSC, or React Server Components. So it has a support for RSC, or React Server Components, out of the box. Another one, simultaneous multiple ENV targets. So, build and optimize for multiple environments together. For example, browser, server, edge, SSR, React Server Components. And last but not least, Next.js support. So Vercel is planning to use Turbopack to create a remote cache that would have developers have this single source of cache and distribute across the team. So the benefit of having this remote cache is you can use it also in CI, making your CI build time shorter than usually because you're using cache. And then it can also be used by your development team. So startup time, you can get away with the startup time or cold start because everything now is cache, and your developer team or your colleagues are getting it from the cloud. So that's the benefit of having this remote cache. So why replace Webpack? There's so many problems here. So one, Webpack, was created 10 years ago, retains its dated architecture despite web development's significant growth. So another one would be Webpack's architecture isn't suited for large-scale, incremental builds, and it's difficult to fix due to numerous dependent plugins. Another one, changing Webpack's architecture while maintaining backwards compatibility is challenging. So as there's a risk in breaking users' existing implementations. Cache invalidation is also a part of this problem. So it's often too sensitive, causing extensive rebuilding when small changes are made. And incremental builds, or cache invalidation. So that's incremental builds, by the way, not cache invalidation. So, so in incremental builds, cache lookup, helps skip redundant work, but with many modules, it can lead to considerable cache lookup costs. So, going to change that one day or later. So, let's go to Turbopack's architecture. So, first layer, there's like several layers here. So, Vercel created this layering system using Rust as the base. Rust offers parallelism, shared memory, and security, but it's more challenging to write than JavaScript. So to encourage plug-in development encourage us developers to write plug-in, Vercel supports both JavaScript and Rust for plug-in interfaces, and then developers can start with JavaScript and then port it to Rust afterward. Then after that, it comes Turbo Engine, a core engine for common tasks like caching, invalidation, and incremental builds. And Vercel is using this SWC as transpiler or parser. So this is a modern transpiler built in Rust that replaces Babel. By the way, SWC is popular also. So they didn't create their own; they just they're just using this existing tool, SWC, which is smart. So after that, on top of those two, we have this Turbopack, so a bundler handling CSS, static assets, WASM, images, fonts, and more leveraging SWC. And then frameworks can use that, but for now, Next.js has this built-in support for Turbopack, but the plan is to include also other frameworks and UI libraries like React, Vue, Svelte, Angular, Solid.js, and Quick. So why Turbopack is so fast? So So Turbopack's impressive speed is attributed to its incremental computation engine. So we can take a look here. So in a typical bundler, the process involves reading files, right? Bundling them, concatenating them, and performing multiple tasks. So, however, Turbopack takes different approach, by keeping track of the inputs and outputs of each function. During the first run, it reads, bundles, concatenates the files, and remembers all the outputs. On subsequent run, if a specific file such as SDK-TS here, if it's modified, Turbopack only needs to redo the steps related to that file, and it doesn't need to read or bundle the unchanged files like this API-TS. So Turbopack smartly he knows what to do with this SDK-TS and just ignore other files that didn't have any change. So this incremental computation and the native speed of Rust are responsible for Turbopack's speed performance. So interestingly, the turbo engine itself is not involved in the bundling process. Its main function is to save the results of the functions. Now, getting started with Turbopack, you can use npx. So just npx create next app. And this is the template that they have in their website, so you can get started with it quickly. And you would notice in the script, after generating this boilerplate, that the dev script is now this flag, turbo flag, next dev, this dash turbo. So this means that it's going to use this Turbopack for bundling the application. Demo, yeah. Let's see. I don't have much demo here because what you can see here, it's actually this flag here. And then there's no configuration whatsoever. This is the first difference between Turbopack and RSPack, which we will see later. And it doesn't support Webpack, of course. No configuration file. You can only see it in the build folder here. If you search, you can see Turbopack, but nothing else. I can run this, but it's still the same that you'll see even without this. So there's no code that aside from this script that you will see that makes it different from a normal Next.js application, except for this. So let's move to another one so we can have the RSPack. So RSPack. So ByteDance and Valor Software introduced RSPack to the open source community. If you have no idea what is ByteDance, they are responsible for this application. So the tech giant behind popular platforms such as TikTok, that's ByteDance, and they're dogfooding this RSPack, which is their own bundler built using Rust, and they're using this in their production. And it's a good thing that they're sharing it with us. Same as here, Turbopack. It's also a Rust-based web bundler. So features. Let's check out the features of this RSPack. So fast startups, combining TypeScript and Rust with parallelized architecture to bring you ultimate developer experience. Similarly, Lightning HMR, same as in Vite, same also in Turbopack. You have this incremental compilation mechanism, provides superior hot module replacement. What it does have, which is different from Turbopack, is Webpack compatible out of the box. So if you have those Webpack skills, like configuring Webpack, ejecting CRA, and then optimizing your application, you can bring that skill to RSPack because you can just basically get those configuration that you you've written in Webpack and then bring it here in RSpec. And I'm going to show you later the config file here in RSpec in the demo. What else? Barriers included. So out-of-the-box support for TypeScript, JSX, CSS, CSS modules, Sass, and more. Production optimizations, so core optimizations such as tree shaking and minification have integrated implementations rather than deferring to plugins. And framework agnostic, so not bound to any front-end framework. Everyone can use it. Getting started with RSpec, npm create RSpec at latest, so you get the latest version. And you will see in the script block, the dev, it's using this RSpec command space serve. And here's the rspec.config. Actually, here it is. And as you can see, there's similarity. Of course, this is compatible with Webpack. What you've written in Webpack, you can bring it here. So that's really nice to have because if you have this configuration and you want to bring it to this bundler, you can do that. So I don't have this. Let's check out. So here you go. Here's just an example of, you can add more plugins there if you want. So this is where you can start writing, some of existing plugins that you've written in your Webpack configuration. And exactly the same. This is React. No other extra code that you'll see here that related to RSpec. Oh, sorry. Thank you. I would do this again. Main display. Mirror, please. Oh, yep. So going back, RSpec config. Yep, this is where you're gonna put it. Plugins, things that you've written before. So basically, you can reuse whatever thing you've learned in configuring Webpack. You can bring it here. Aside from that, you wouldn't see anything that relates to RSpec. You can see the main JSX here in React. There's nothing related to RSpec. app.jsx, nothing. So basically, it's just in the RSpec config. And package.json, the dev in the build, RSpec serve, RSpec build. So nothing special, just the RSpec config. So for the RSpec, recently and now they're supporting Vue.js. There's a Vue.js loader, a React, Angular, planning to, Svelte, solid and quick also. So it's gotta be quick. So in summary. We're going to go to summary. It's going to be quick. So Turbopack and RSpec, so these are Rust-based bundlers. They gave you lightning-fast HMR, which is also beneficial for developers and it's going to help us in our productivity. RSpec has Webpack compatibility, while Turbopack does not have. And with Turbopack, RSpec improve, our improve DX in our day-to-day work. So resources, just to show you, Vite.js.dev, just to see Vite or to know more about Vite. For the Turbopack, turbo.build/pack. And for the RSpack bundler, here's the link, rspack.dev. If you have questions, you can ask me in after this or during the talk, since I still have time. So yeah, thank you very much for listening.